Assalamu alaikum. Today we will continue with chapter 5 about forces. Before we start, you need to prepare your stuff and follow these instructions. At the end of this video, you will be able to name some of the forces mentioned before, indicate or specify their characteristics. In the previous video, we learned about the type and characteristics of the force, weight or gravitational force, which is done due to the attraction of Earth. We said that this force, the point of application of this force is the center of gravity, since it's a force acting from a distance. The direction of this force is always downward toward the Earth, and the line of action is vertical. The second force we talked about was the tension force. This force occurs in the presence of a wire, a string, or a spring. It is a contact force, so the point of application is the point of contact between the object and the wire. The line of action and direction are always toward the wire or string used. Experiment time. To learn about more forces, please pause the video and prepare a ball and a table so that you can perform those experiments. Experiment 1. Materials needed: a ball and a table. Procedure: release the ball above the table until it sits still on the table. Let's see how. Try to solve the following questions. Is the ball moving anymore? What do you think? Is it moving? No, it's not. If we remove the table, will the ball keep moving? What will happen to the ball? Yes, it will keep moving. It will fall down. Can we say that the table exerts a force on the ball? Yes, of course we can. Why? Because the table sets the ball at rest. It was moving, then it sets it at rest. What is the effect of this force? This force stops the downward movement of the ball. It supports the ball. Choose the correct answer. The force exerted by the table on the ball is called, what do you think? Is it magnetic force, muscular force, or normal reaction of a support? Choose the most reasonable answer. Do we have a magnet? Did we push or pull the ball? Or it was the normal reaction of a support? It was the normal reaction of the support. It was the normal reaction of the table, which is the support here. This force acts from a distance or acts upon contact? What do you think? Did the table stop the ball before being in contact with it, or when it was in contact? Of course, when it was in contact. It can't act from a distance, so this force acts upon contact. Very good. Let's identify normal reaction of a support, symbolized with capital N above it a vector. The normal reaction of a support is a force exerted by a support on other objects which are in contact with it. This force is symbolized by a point of application. This point of application is the point of contact between the support and the object, since this force acts upon contact. You can take any point of contact between the support and the object in contact. Note that in higher grades, you will take the midpoint of the surface which is in contact with the support. From this point, for example here, from this point of application, we will draw the vector. The second characteristic is the line of action. Note that the line of action is always perpendicular to the support. If you noticed here, before we draw the vector, we drew a perpendicular line. We took a 90-degree angle, and we draw the vector. Here also the line of action here, it's perpendicular to the support. The direction is upward. Now experiment 2. Materials needed: a ball and a table. Procedure: using your hand, roll the ball on the table. Let's roll it. Choose the correct answer. The force exerted by the hand on the ball in this experiment is called, what do you think? Of course, choose the most reasonable answer. Magnetic force, muscular force, or normal reaction of a support. Since we use our hand and our hand is made up of muscles, so the force exerted by the hand on the ball will be the muscular force. Excellent. This force acts from a distance or acts upon contact. What do you think? Can we move the ball without touching it? Can you move it? Of course not. So this force, which is the muscular force, acts upon contact. Let's identify. Muscular force, it's represented by a capital F, on it a vector. The muscular force is the force applied by the muscles of a part of the body, like the arms of the leg. If you notice here, the man is pushing the wagon. He is pushing it by his hands, so he applies on it the muscular force. The point of application of this force is the point of contact between the muscles of the hand or the hand and the arms of the wagon. The boy is riding the bicycle, so he exerts on the bicycle muscular force by his legs, since the legs are made up of muscles. The point of application of this force is the point of contact between the legs and the bicycle, the same as this man who is pushing the car. He is exerting on the car muscular force, since he is pushing by his hand and the hands are made up of muscles. The point of application of this force is the point of contact between the body and the object that we are doing on it the force. The line of action and the direction depends on each situation. For example, here the line of action is horizontal and direction is toward the right, while here the line of action is oblique and the direction is downward to the right, while in the third case the line of action is horizontal while the direction is toward the left. Let's practice. Please open your booklet on worksheet 7. As we did before, we should name the forces acting on the object we have. We should name the force, indicate its type, and list its characteristics. A box is put on a table. Please pause the video and try to name the forces acting on this box. Let's continue. When we are asked to name the forces acting on any body, we always start with the weight, since all the objects on Earth are attracted by the gravitational force, the weight. So let's list its characteristics. First of all, this force is acting from a distance. So the point of application is the center of gravity. We draw it by drawing the diagonals. The line of action is vertical toward the earth and the direction is always downward, as we always mention. The second force, if you notice here we have a table. A table is considered as a support. The second force we're gonna talk about is the normal reaction of a support. This type of forces is a contact force. Let's try to represent it. We said before the point of application is the point of contact between the box and the table or the support. So we're gonna take any point on the surface and draw it. Note that the line of action is always perpendicular to the support. In this case, when we draw it, it is vertical. Of course, we should draw it perpendicular to the surface. The direction in this case is upward. So let's write them. It is, first of all, it is a contact force. The point of application is the point of contact between the box and the table. The line of action is always perpendicular to the support. In this case, it's vertical as shown here. And the direction is upward. The magnitude is represented with capital M, and of course the SI unit is Newton. Same questions. You should name the forces acting on the box, indicate its type, and list its characteristics. Please pause the video and try to solve it by yourself. Let's continue. A man is pushing a box on a table. What are the forces acting on this box? Of course, first is the weight. Let's represent it. We're gonna draw the diagonals of the box. The point of intersection between them is the center of gravity. The weight is always downward, vertically downward. It's acting from a distance. Its type is acting from a distance. It's characterized by the center of gravity as point of application. The line of action is vertical as shown, and the direction is downward as drawn in the figure. The second force, and because we have a support, it is the normal reaction of a support. Also, we should represent it. We're gonna take any point of contact between the table and the box. We're gonna draw a perpendicular to the support. Now we can list its characteristics. First of all, it is a force acting upon contact. The characteristic of this force, the point of application, is the point of contact between the box and the surface that we have. The line of action is always perpendicular to the support. In this case, it's vertical. And as shown in the figure, the direction is upward. The third force is the muscular force. How did we know? We have a man pushing a box, so the hand of the man is made up of muscles. This force is a contact force, so the point of application is the point of contact between the muscles of the hand or the hand and the surface of the box. We're gonna take any point on the surface. The line of action and direction are according to the case here. The man is pushing it toward the right. So the line of action is horizontal and the direction is toward the right. Let's try to write the characteristics. First of all, this is a contact force. The point of application is the point of contact between the box and the hand. The line of action is horizontal and directed to the right. The magnitude is represented with capital F and the SI unit is a Newton. Till now, we have learned the type and characteristics of weight, tension, normal reaction of a support, and muscular force. Are there other forces? We're gonna know in the next video. Please study by heart the table of figure 4 and 6 in worksheet 7 and write it as an auto dictation. See you next time. Thank you.